All right, so here we are in 12.5 on the fundamental theorem of calculus. So this is going to be an introduction to that. Then we're going to evaluate definite integrals, and then we're going to recognize a definite integral and average value. All right, so here we have the introduction to the fundamental theorem. So suppose the daily cost function for a small manufacturing firm is given in dollars by the C of x equals 180x plus 200, where x is between 0 and 20. Then the marginal cost, remember that's the derivative, is given by C prime of x is equal to 180. So when you take the derivative of the 180x, that just goes to 180. Now what is the change in cost as production is increased from 5 units to 10 units? That change is going to be equal to what? Well, it's going to be C of 10 minus C of 5, which is going to be, if you plug in 10 and 5 in there, it's 180 times 10 plus 200 minus 180 times 5 plus 200, and that ends up being 900. Now, notice that the 180 times 10 minus 5 is equal to the area between the graph of C prime, which is here. So that's, if we look at our table or graphs here, that's 180x plus 200. And so this is going to be our difference. That's going to be the 900. Or we can look at it as, well, here's the derivative, that's 180, and we're looking between 5 and 10, and it's going to be the area within here, which is just 180 times the 10 minus 5. So the width times the height, basically, and that's going to give us 900 as well. Now, this is represented as, the integral from 5 to 10 of 180 dx. And so both of those give us the same answer because when you take the integral of that, basically, you're going to end up just plugging things back into this, and you're going to get the value out. So let's look at that here. We have the change in cost versus area under the marginal cost. Now, the daily cost function for a company is given as, and now we're not going to use this function. We're going to cross that one out, and we're going to use this function instead. So we're repeating example one for the match problem. So now we're supposed to graph C of x for x between 0 and 20, calculate the change in cost from 5 to 10, and indicate that change in cost on the graph. Then we're supposed to graph the marginal cost, C prime of x for 0 to 20, and then use geometric formulas. And what we'll do is we'll go to the back and we'll forget about that. We just know that it's going to be a trapezoid. So it's going to be 1/2, one base plus the other base times the height. And so we're going to calculate that. And then part C, we're going to compare the results in A and B. All right, so first things first, we're going to graph this. Well, if we graph that, what's going to happen is we're going to have some kind of a quadratic, and it's going to start at what? It's going to start at 625, and it's going to kind of go up. It's going to look something like that. Okay. And so, 20 is going to be over here. This is 0. We know that this is 625 at 0 because I plug 0 and 0 in there. And so now we want to do between, it says 5 to 10. So let's see if we can split this appropriately. So that's 5 and 10. It's not appropriate, but it's close enough. And so with this one, we're going to do two things on one graph. So that's what we're doing here. We're kind of drawing this. Now, if we want to calculate the change in cost, so basically we're looking at the height here and the height here. And so we're looking at what is that difference, okay? And so that's going to be what? Well, that's going to be C of 10, parenthesis, minus C of 5. And so we plug in 5 and 10 into this equation, and we get that out. So if we do that, let's plug those in to a calculator. And where's my calculator? Here we go. So let's go and plug that in here. So let's say, okay, let's have, we had a negative 7.5 x squared, and then plus 305x plus 625. Now our window, let's go 0, and we wanted to get to 20. Let's go by 5 maybe. Minimum 20 is okay for below, but with that 600, let's go up, I don't know, 5,500. I don't know how high we need to go. Let's go by 500 then. And now what's our graph look like? All right, so that's our graph. Apparently I have a stat plot on here. So let's turn stat plot off so we don't have to see those dots. All right, so that's what it looks like. So between 5 and 10 is what we're looking at. All right. And so what we can do to figure out those values instead of actually, doing the calculation, we can do 5. And so we're going to get 1962.5. And if we plug in 10, we get 2925. All right. So now we get 2925 minus 1962.5. So we get 962.5. All right. So coming back over here, we know that that difference is 962.5. All right, so that is part A. That's to indicate change in cost on the graph, so that's the change in cost. We know C10 minus C5. So we have everything we need for that one. So B says graph the marginal cost. Well, what is that going to be? Well, C prime of X is equal to what? Well, that's going to be a minus 15X plus 305. So that's going to be about here, 305. So that's at times 0. At 20, that's going to be what, 300? So that's going to be at 5. So that's just going to be barely above it. So there's going to be a straight line. We can draw it. Consider that a straight line, and that's 5 there. It's going to be pretty close to 0, but it's not. And so that's going to be kind of our derivative. It's just that straight line. And what we're going to look for now is we want the area within here. All right, so like I said, this is a trapezoid because if we blow that up, it looks something like that. And these are parallel. That's our one angled line that's straight. And so what we need to do is we need to find, kind of this point and this point. So then we know our heights, and then we also need to have our distance from here to here. So that's the 10, that's the 5. So we know that distance, the delta x, is equal to 5. So now calculating those, what we're going to do is we're going to go over back to our calculator. And we'll go back up here. And if we take the derivative of that, then that will give us what we need. So what we need to do then is turn this one on and graph it. And so that's what it looks like. Like I said, it's hard to draw that straight line because you need so much space up there, but that's what it is. And so now we're going to say, okay, well, let's find out the value at 5. And we want the blue line first. We got that, but now we need the red line. So that's going to be 230. And the other one is at 10, and it's 155. So 230 and 155. So if we go back here, we're going to have well, let's actually go back over here and write down what we have, and then we can calculate it. So the trapezoid area is equal to what we're gonna have is like a base. Well, let's call this base, and this one maybe call it C, and then this is that. So it's gonna be B plus C over 2 times our delta X. And so that was going to be, we had what, 155 plus 230 divided by 2 times 5. And so then if we do that, let's go back over here now that we got all that written down. So we had 230 plus 155 divided by 2 times 5, and we get 962.5 again. Amazing how that works. And so where's my marker? Here it is, 962.5. And so that means the area under this is 962.5, which is also this change here, okay? All right, so what else do we need? Calculate the area between that and that. Now compare the results. Well, what does it show? It says, well, the change in the uh, cost from 5 to 10, it's gone up by 962.5, and the area under the curve of the C prime X is going to be the marginal cost. That is going to be 962.5. So both of them are equal. So I'm not going to write that out, but that's what it is. The change in cost from going from 5 to 10 is 962.5, and the marginal cost area under the curve for that is the same. It's 962.5. All right, so let's pause there and we'll come back for some more.